Final lesson for the Pythagorean theorem is 3b.3, and we're just going to do some applications, aka word problem stuff with Pythagorean theorem. So a lot of times in these, if we do not have a picture, we want to go ahead and actually draw a picture to go with it. So we're going to start on page 11 in your packet, and I know that's kind of funny and kind of weird, but on page 11, we're going to start with word problem 6, and we're going to go down through 10 on this particular page, and then you'll go back and you'll finish up the word problems on page 9 and 10 as the practice problems for this lesson. So starting with word problem number 6. In a computer catalog, a computer monitor is listed as being 19 inches. This distance is the diagonal distance across the screen. So if you have a smartphone, or even if you have a smart watch or something along those lines, anytime they talk about a screen size, it is actually the diagonal distance across, which we've learned. If you think about any screen, the diagonal distance would actually end up being the hypotenuse here, because it would be the right across from the right angle on the screen. So for this one, the screen measures 10 inches in height, and what is the actual width of the screen? So on this particular one, let me just draw it a little bit larger here. So here's our screen. It's telling us that the diagonal is 19. The height of the screen is 10, so it wants to know how wide is it across the bottom. So 19 here is going to be our C, and these are going to be A and B interchangeably. So A squared plus B squared equals C squared. I'm just going to put it as A plus B squared equals 19 squared. It's going to be 100 plus B squared, and 19 squared is going to give me 361. So I'm going to subtract 100, and I get B squared is equal to 261. And the square root then, because I need to do square root on both sides, B is equal to, I get 16.15, so 16.2, but it does ask me what's the actual width to the nearest inch. So this is just going to say 16 inches wide. So on word problems, we do have to be pretty careful here, making sure that we answer the actual question that they are asking. So to the nearest inch, 16 inches wide. All right, word problem 7. Miss Green tells you that a right triangle has a hypotenuse of 13 and a leg of 5. She asks you to find the other leg of the triangle without using paper and pencil. What is your answer? So real quickly here, the hypotenuse is 13, the leg is 5, and she wants you to do this one. So what she's getting at is the idea that this is a Pythag triple. And if you go back in your notes packet here, back to page number 3, Pythag triples were at the bottom, and if you remember, we flagged 2 of them, 3, 4, 5, and 5, 12, 13. So because this one's a 5 and a 13, and it's missing the leg, the missing side is going to be 12 because it's a Pythag triple. So we don't even have to do the math on that one. If you notice that you have a Pythag triple, you're welcome to just write down what the number is and write down Pythag triple to represent your work. Word problem number 8. Two joggers run 8 miles north and then 5 miles west. So we're going to start here. We're going north 8 miles, and then we're going west 5 miles. Remember, northwest, north-south, northeast, north-southeast, southwest are all going to give you that right angle there. What is the shortest distance to the nearest tenth of a mile they must travel to return to their starting point? So to go back to your starting point, your fastest going in a straight line, which would therefore create your hypotenuse C. So we have A squared plus B squared equals C squared. 5 squared plus 8 squared equals C squared. 25 plus 64 equals C squared. So 89 equals C squared. Take the square root, and the square root of 89 to the nearest tenth is going to be 9.4 miles to return. So we can go ahead and round that one right there. Word problem number 9. Oscar's doghouse is shaped like a tent. The slanted sides are both 5 feet long, and the bottom of the house is 6 feet across. What is the height of his doghouse in feet at its tallest point? So if this is all the way across 6 feet across the side here, this is going to be a 3. And if you look, so we have 3, missing spot, and 5. And if you remember from that Pythag triple that we just talked about, the height would be 4. So the height is 4 feet. Now, if you didn't remember that, could you go ahead and set up 3 squared plus B squared equals 5 squared, 9 plus B squared equals 25. 5, subtract the 9, b squared equals 16, and we get b is equal to 4 by plugging it back in. But if you realize this, and then you could just put Pythag triple. So if you just went ahead and wrote that down, Pythag triple would be a good enough reason. Final word problem for the lesson today. Word problem 10, Seth made a small rectangular table for his workroom. The sides of the table are 36 inches and 18 inches. So we have a rectangular table, 36 inches and 18 inches. If the diagonal of the table measures 43 inches, so 43 right here, is the table square? A table which is square has right angles at the corners. So this one is always a little confusing. So we want to know, is this square? In other words, is this, in fact, a right angle? So what we're really checking is, do we actually have a right triangle? So if you remember from practice on day 1 and day 2 of this particular unit, we said go ahead, plug everything in that you have, and then question mark, because we're trying to figure out if this is actually going to work. So we get 324 for 18 squared, and we get 1,296 for 36 squared. And for 43 squared, we get 1,849. So if I'm adding up the left-hand side, I get 1,620 is equal to 1,849. And that is not true. So that means his table, unfortunately, is not square, which means even though he tried really, really hard here, he still did not actually make a perfect rectangular table because this is not exactly 90 degrees in the corner here. That's it then for the final lesson for applications for Pythagorean theorem.